हेलो एवरीवन। इस वीडियो में हम डिस्कस करने जा रहे हैं वेक्टर स्पेस। वेक्टर स्पेस हम क्यों पढ़ रहे हैं, मोटिवेशन क्या है, एंड वी विल डिस्कस फर्दर द डेफिनेशन ऑफ ए वेक्टर स्पेस. Basically, first of all we will see that what is the motivation of a vector space. Vector space is a general idea of the familiar set of vectors in 2 or 3 dimensional Euclidean space. We see here this is the Cartesian coordinate system where we will see that x1 y1 x2 y2 are their points. Okay, any points in xy plane. We can also say xy plane, or we can also say r square. Both are the same thing. If I will talk about 3D system, Cartesian coordinate system, so there will be a point x1 y1 z1. So this is, we can say, r cube. If I will say r square, so the elements of r square will be like this, and the element of r cube will be like this, r cube. Okay, so here we will see that for example, x equal to, I am saying that Cartesian coordinate system, so where our element x dash x vector, x is a vector, and the vector is like that x1 comma x2, and y vector, this is y1 y2 in xy plane. So this xy plane is also called plane r square. Okay, now I am going to move the forward for the notion of an addition of two vectors. How can we add two vectors? This is the basic simple thing we have studied in the 12th class. Okay, so हम यहाँ देखेंगे कि x is also vector, this is also in a vector, y is also vector. So we have above seen that x vector is this and y vector is this. So we will do the sum of these two vectors, and these two vectors will be added by tuple wise, means this x1 will be added to only x2, y1 will be added to y2. This is the addition of two vectors. So this addition is basically, we have already seen in 12th class the parallelogram. Like there are two vectors, x vector in this direction, y vector in this direction. So x plus y will be, this is the resultant vector if we will talk about that. So this vector, this plus is here, this addition is represented in the resultant vector of x plus y. So that will be like this. Okay, now if we will multiply alpha is any scalar, any real number. If we will multiply alpha to the vector x, so it will be like alpha, and our given vector is x1 comma x2. Okay, so we will multiply alpha x1 alpha x2. Alpha is any real number. So if I talk about how can we say that in the geometrical meaning of this alpha x, so basically like this. If we have a vector x bar in this direction, so alpha x will be on in this direction if our alpha is positive. If our alpha is negative, that will be in the negative side of that. Okay, so this is this thing. Now coming on that zero vector. So basically zero vector is like that. I am going to discuss zero vector. So zero vector में हम देखते हैं कि zero vector is moving like this. If we have a vector x and we will add zero vector from that vector, so x vector will automatically come. Okay, and when also we get the zero vector, if x plus, we have already seen addition of two vector, then we will multiply minus x vector, so that will come to the zero vector. Okay, subtraction of two vector we can also write with the above two properties: addition of two vectors plus scalar multiple of the vector. So this is the addition of two and subtraction of two vectors. Now we define the notions of a vector space, but before defining the notion of vector space, we have need to define the definition of a field. सो फील्ड इज बेसिकली नीड, हमें वेक्टर स्पेस डिफाइन करने के लिए एक फील्ड चाहिए, वेक्टर स्पेस और फील्ड एफ फील्ड एफ, दिस इज डिनोटेड नोटेशन ऑफ द फील्ड एफ कैपिटल एफ. So here we will see that the definition. So the field of real number, the field of complex number, we can say that. So the definition of field is a field is a non-empty set of elements equipped with two operation, addition and multiplication, satisfying the following properties. These are the following properties. If we have, first of all, we have a non-empty set, and this non-empty set have two operation. Okay, two operation, that is addition and multiplication. I will write here. F is a vector space with two operation. F is any non-empty set with two operation. So first property satisfying closure. Closure means if we will two vector, two elements in F. F is a non-empty set, so we will two both elements. So we will be add a plus b belongs to F. Okay, and if we will take multiplication, so that is also means we can say that closure property should be satisfied under the operation addition and multiplication. Okay, means we have two elements in field F, then we will add both the elements that should be belongs to in that F, and if we will take multiply of these two numbers, that will also lies in the F. Now coming on this second property, commutative. Commutative is with respect to addition or multiplication, means we add two number a plus b and b plus a, both are equals, so then we can say that commutative under addition. If a dot b equal to b dot a, under multiplication, for all ab belongs to that field F, so this is a commutative property. Next, coming on the associativity, that also should be satisfied with respect to addition and multiplication. Next is additive identity. Additive identity is like that if we have an element A which is in the field F, okay, and what we will add to that element, that come automatically A. So means we have to add 0, that will come A. So means 0 is an identity element, additive identity. Multiplicative identity means A dot B equal to A. So what should be B? B is 1. So 1 is called the multiplicative identity. Okay. Additive inverse. Additive inverse means if we will add an element B and that will come to identity element. So B will be minus A. Multiplicative inverse, same, if we will multiply by that, should be come to identity, multiplicative identity. So these 7 property, any non-empty set satisfy these 7 properties, then we can say that that given set is a field. Okay, so these are the examples. The set of real numbers should be satisfy all these properties. So the set of real numbers is a field. The set of complex number, that is also filled, and the set of rational number, that is also filled. So now I am going to discuss the definition of a vector space. So basically vector space, V be a non-empty set of vectors, means we will choose a non-empty set and all the elements of this set are vectors. Okay, along with two operation, addition and multiplication, defined over a field F. Defined over a field F is called vector space if it satisfies the following properties. Closure under addition. Here we see that all the elements of capital V are the vectors. Vectors means U vector. The elements of V are U1, U2. So these elements are coming to the, what is the role of, we will see that what is the role of the field. Role of the field is that these U1, U2, UN, that comes to from the field F. Okay, so हम ये डिस्कस कर रहे हैं, V वेक्टर लेंगे, then we will take additions. So U plus V and V plus U are both the same thing. So this is a closure under addition. Now I am going to discuss closure under scalar multiplication. So we will multiply C dot U, that is also in belongs to, should be belongs to V. So C can also write addition of two number, addition of two scalars. These are coming from the field F. Alpha dot beta, that is the product of two if we can write, so that is also satisfy the same property. Additive identity, there exists a zero vector. If we will do x plus theta equal to x for all x belongs to say, so this theta will be zero vector. So this is the additive identity. If these three properties should be satisfied with by the V, so that V is called in a vector space over the field F. So I already told you that what is the role of the field. So this is the role of the field, because all the elements inside the vectors, like I will say that u vector, so these u1 u2 un, these are elements are coming from that field. Okay, so this is the definition of a vector space. In the next video I am going to discuss the examples of the vector space. Okay, thanks.